Let's now look at this problem concerning the normal distribution. A small college has 5,000 students, which consists of 47% men and 53% women. A simple random sample of 200 students is selected. What is the chance that fewer than 100 are men? So we're looking for the chance that if I have a sample, that I have a probability of a count which is less than 100. Here I have a large sample, and so I can use the approximation of the bell curve of a normal distribution being less than 99.5. It is 99.5 because if I imagine that I have my distribution, which in this case is a hypergeometric distribution because I'm drawing without replacement, 100, 99, 98, and I kind of draw rectangles on top here. So just a quick cartoon to see how the picture goes. Then the area that gets shaded is going to be everything that is less than 100. And so my endpoint will be right here, which is at 99.5. So hence going down by a half as opposed to up by a half. Now remember, I make this continuity correction when I'm approximating either the binomial or the hypergeometric distribution by the bell curve, and not when I am simply using the bell curve on its own. Okay, now to proceed with this problem, we need to figure out the mean and the standard deviation. The mean will be equal to the size of the sample times the probability of success, which in this case would be 200 times 0.47, which works out to be 94. The standard deviation requires a little bit more work. That's equal to the square root of capital N minus little n. And I should draw a big square root so I can see that better. Square root of capital N minus 1 over square root of n times pi times 1 minus pi. So in our case, this will be equal to the square root of 5,000 minus 200 over 5,000 minus 1 times the square root of 200 times 0.47 times 0.53. Okay, so using Excel to do the calculation, we have the mean was equal to 200 times 0.47, and the standard deviation is equal to the square root of 5,000 minus 200 over 5,000 minus 1 times the square root of 200 times 0.47 times 0.53. And so hitting enter, we get our standard deviation is about 6.413. Or 6.916. So there's the formula in Excel, and of course something similar would apply using a calculator. So the answer is about 6.916. So let me clear out the calculation here now that we have it. And so the standard deviation works out to be 6.916. So that takes us to figuring out this probability that x is less than 99.5. So I've got all this information. I'm going to get rid of it on the screen for the sake of space. So the probability that x is less than 99.5, that is equal to the probability that a standard normal random variable is less than 99.5 minus the mean of 94 divided by the standard deviation of 6.916. So that basically means convert the 99.7 or 99.5 into standard units. So the z value is going to be equal to 99.5 minus the mean 94 divided by the standard deviation of 6.916, which gives me a z value of 0.795. And then I either use Microsoft Excel, or else the table, or else a calculator to figure out the probability. Using Excel, the command would be normsdist of the number that we just got, 0.795. That returns the area to the left, and that of course is exactly what I want in this problem. I have the area to the left of 0.795, which is about right here. And so using the normsdist command, we get the final answer, which is 0.7867. So rounding to 4 decimal places, the answer would be 0.7868, rounding to 4 decimal places.